Hello everyone. We'll practice now some questions for the system-wide quiz 2. Question 1. What is the correct Lewis structure for hydrogen chloride? This is the correct answer. How we get this answer? Hydrogen is in group 1 and has 1 electron in outer shell. Cl is in group 7 and has 7 electrons in outer shell. This means that each atom is going to share 1 electron, forming a single covalent bond. So this will be the final structure of HCl molecule. Question 2. In chemical reaction, energy as heat must be added to the reactant, number of atoms is conserved, mass of products greater than mass of reactants, number of atoms in the product is double that of the reactants. B is the correct answer. Why? Because in any chemical reaction, the mass of the product is equal to the mass of the reactant. Number of atoms in the product should be equal to the mass of the reactant. Question 3. Which coefficient correctly balance formula equation? And the formula is given to you. So let's balance this equation. NH4NO2 gives N2 plus H2O. NH4NO2 is a solid, N2 is gas, and water is liquid. To balance the equation, firstly look for nitrogen. I have on the left side 2 nitrogen atoms. And on the right side, I have also 2 nitrogen atoms. So nitrogen is balanced. Hydrogen. We have 4 hydrogen atoms on the left side, and we have only 2 on the right side. So here, we need to add 2 in the coefficient, so to have 4 hydrogen and get the hydrogen balanced. What's left is to look for oxygen. I have O2 means 2 oxygen on the left side, and also we have 2 oxygen on the right side. So the equation now is balanced. Why is it important to balance chemical equation? To predict the reaction type, balance doesn't have anything to do with the type of reaction. To be able to predict the product, to satisfy the law of conservation of energy, or to satisfy the law of conservation of mass. Yeah, that's true, to satisfy the law of conservation of mass, to make sure that number of atoms in reactants equal to the number of atoms in products. Here we satisfy the rate of conservation of mass. This question gives net ionic equation for the reaction, if any, that occurs when aqueous solution of H2SO4 and KOH are mixed. It's very clear that this reaction is between an acid, H2SO4, and an alkali, which is KOH. Both of them are aqueous. This type of reaction here is double replacement reaction. In double replacement reaction, K is going to exchange with H their position. Positive ions exchange their position, giving K2SO4 plus H2O. We should balance the equation first before we start writing the ionic equation. To balance the equation, look for the number of potassium. I have on the right side 2K and on the left side 1. So put 2 in the coefficient, potassium will get balanced. Sulfate, we have 1 SO4 on the left side and 1 SO4 on the right side. So sulfate is balanced. Lastly, we should look for hydrogen oxygen. On the left side we have 2 hydrogen atoms. On the right side we have 2, so hydrogen is balanced. Oxygen, 1 O, no, it's 2 O, and on that side I have 1 O. We need to balance oxygen. In order to balance oxygen, I will put here 2 in the coefficient. So oxygen now is balanced, but hydrogen is not yet. Here, now I have 4 hydrogen on the right side, and I have, I have also hydrogen, 4 hydrogen on the left side, because I have 2 H from here and 2 hydrogen from the KOH. Now all the equation is balanced. After that, we need to write ionic equation. To write ionic equation, we need to separate the molecules into ions. So H2SO4 will transform in hydrogen positive ion and sulfate negative ion. KOH will be changed into potassium positive ion and OH2OH negative ion. This is going to give K2SO4, it is 2K plus SO4, and water, which is H2O. Only water which is not forming ions. Everything else is making ions because all of them are aqueous solution. If all of them are aqueous solution, so they should form ions. Okay, the next step is to cancel out the ions that are repeated on both sides. We call those ions spectator ions. Okay, so look for SO4. I have 1 SO4 on the left side. We'll cancel out with 1 SO4 on the right side. 2 potassium ions on the left side will get cancelled with potassium ion on the right side. And what's left is the final ionic equation. So 2H plus 2OH gives 2H2O. And don't forget to write the state. Hydrogen ions are aqueous solutions because originally the original solutions were all aqueous. Now it's very simple to deduce that A is the correct answer because it is the one which match our results. Okay, although it's more simplified because it's not written here 2, but it's correct answer because if you simplify your equation here, it will be 1H plus 1OH gives 1H2O. Let's look at this question. Which of the following is a gas evolution reaction? If a reaction involves hydrogen gas or oxygen gas or nitrogen gas, so it's a gas evolution reaction. It's a reaction which evolves gas. How can we know if they're a gas? By looking at the equation. If the result has G, so it's a gas evolution reaction. Okay, first equation is H2O. You know that H2O is water, but it is not a gas, it's a steam. If H2O released in the form of a gas or vapor, we call it steam. So it is not a gas evolution reaction. Reaction 2 doesn't involve any gas. Reaction 3, it involves ammonia, NH3 gas. Okay, here we have gas, but the gas is in the reactant side. The gas should be in the product side. Evolution. Evolution means gas is a resultant. So we are looking for an equation where gas is a resultant. Question 8. Which of the following pairs of solutions produce a precipitate when combined? How can we know if the precipitate is formed or not? Let's practice the equations. Equation 1. What does it give? Which of the following pairs of solution produce a precipitate when combined? All of those are solutions, mean they are all aqueous solutions. So we have aqueous solutions of two compounds, and he's asking which of them give precipitate. You'll be given in the exam solubility table. In the solubility table, you can decide which of them is soluble and which is insoluble. So let's first make the equation, find the product, and then look for the solubility table. Here, K will come with SO4 and Na with Cl, giving NaCl plus K2SO4. This reaction will give NH4OH and KCl. Third reaction will give, yes, KNO3 plus FeCl3. Last reaction will give AgCl plus NH4NO3. After doing that, look for the solubility table at the end of the paper. Okay, you will recognize that AgCl is the only solid compound. So the solution which give a precipitate when combined is NH4Cl with silver nitrate. This reaction AX give A plus X is general equation 4. If you have a big molecule has been broken down into two smaller ones, this means that this reaction is a decomposition reaction. This reaction is asking about a change of word equation into chemical equation. Zinc plus hydrochloric acid gives zinc chloride and hydrogen. By looking in the periodic table, you will know that the formula for zinc is Zn. For hydrochloric acid, you know it from before, HCl, zinc chloride, ZnCl2, and hydrogen, H2. So which of them is the correct balanced equation? Let's look for the balance first. Here I have one zinc on the left side and one zinc on the right side, so zinc is balanced. Secondly, Cl. I have one Cl on the left side and two Cl on the right side. To make this side balanced, you need to add one more Cl, so making it 2. Now Cl is balanced. Lastly, look for hydrogen. We have 2 hydrogen on the left side and also 2 hydrogen atoms on the right side. So which equation which match our balance is equation B, which is not a sign that a double displacement reaction has occurred. Sometimes we call it replacement or displacement. They have the same meaning. Which is not a sign of a double displacement reaction. Gas may be formed, water may be produced, coefficients are equal, a precipitate is formed. All of those are signs of all chemical reactions, not only double displacement. But we haven't seen before the coefficients are equal because in most of equations, coefficients are not equal. You may write 2 on left side and write 1 or 4 on the right side of the equation. But all chemical reactions are assigned by an evolution of a gas or water or precipitate to be formed. Question 12. Which type of reactions are essentially opposite to one another? Okay, we explained before that if you have a compound AB has been broken down into 2 smaller ones, A plus B, we call this reaction decomposition reaction. This reaction is completely opposite to if you get A plus B, you get one big molecule AB. This reaction we call it synthesis reaction. So synthesis reaction is opposite to decomposition reaction. Now we'll practice structured questions. Write the word equation for the following skeleton equation. Skeleton equation is just a chemical equation which doesn't show a correct balance. When you balance it, we call it balanced chemical equation. When you write it in words, it's a word equation. This question is asking to change the skeleton equation into word equation. Copper. So looking in the periodic table, you will see that Cu is symbol for copper. You write copper. Cl2 is formula of chlorine gas. CuCl2 is copper 2 chloride. Remember that if you are talking about a transition element which lie in the middle of the periodic table, you have elements that are located on the middle of the periodic table. These elements are transition elements. Transition elements, when you write their valency, you should show the valency when you write the chemical name. So I should write copper 2 chloride. This is because transition elements often have so many valences. So to show the correct valence or the correct oxidation state, you should show it when you write the word equation. So here copper has a valency of 2, so we should write copper 2 chloride. In this reaction, Na plus H2O gives NaOH plus H2. So Na is sodium, H2O is water, NaOH is sodium hydroxide and hydrogen gas. This reaction or this question use the word equation given below to write balanced chemical equation. So it's the opposite to first question. Aluminium react with oxygen to produce aluminium oxide. So aluminium Al, oxygen O2, aluminium oxide is Al2O3. The valency or the formula, you learned it in term 1. Aluminium locates in group 3 and has a valency of 3, while oxygen is in group 6 and has a valency of 2. So the correct formula for the compound is Al2O3. Last step is balancing the equation. Let's look for aluminium first. I have one aluminium atom on the left side of the equation and 2 on the right side. So add here 2 to make the aluminium get balanced. Finally, you look for oxygen. I have on the right side 3 oxygen atoms and on the left side 2. So the only way to make oxygen balance is to change both sides into 6. So multiply 3, so I have 6 oxygen now on the left side, and you multiply this by 2, you will have 6 oxygen on the right side. But looking again, once you finish balancing oxygen, you should look back for checking balance of other elements. Here, aluminium became 4, so here you need to write 4. So that is the correct balance. 4Al plus 3O2 gives 2Al2O3, and don't forget to write what the states. Aluminium is metal, you know that metals are solid. Oxygen is gas, so it should write G. Aluminium oxide is solid. All oxides are solids. Don't write any liquid or gas for oxides. Use the activity series on page 7 to predict whether each of the possible reactions listed below will occur. For the reaction that will occur, write products and balance the equation and name the type of reaction. First reaction, lithium plus chloride gives lithium chloride. This reaction is synthesis reaction. Remember, A plus B gives AB. This is the general formula for synthesis reaction. CH4 plus O2. If O2 is involved, so it's a combustion reaction. Combustion gives carbon dioxide and water. Any combustion gives carbon dioxide and water. Here, magnesium nitrate plus KOH. So I will put K with NO3, giving KNO3, Mg with OH, giving MgOH2. You then balance the equation and write the name. It's a double displacement or double replacement. Mg plus HCl gives MgCl2 plus H2. Here magnesium displaces hydrogen only, so it's a single replacement or single displacement reaction. Mg is going to displace H, forming MgCl2, and the hydrogen gas will be given out. Au plus FeSO4, no reaction. Why this reaction has been taken place while that reaction doesn't? Looking in the chemical reactivity series, you recognize that magnesium lies at the top of the series and it lies before hydrogen, while Au is the last element in the series and the iron is just above it long distance. So gold does not react with iron salt, while magnesium can react with hydrogen chloride or hydrogen sulfates. So here, no reaction. Last question, write complete ionic and net ionic equation for the following reaction. You'll be given a reaction like that, you'll be asked first to write ionic equation. Any compound, you'll get it in aqueous, you should dissociate it into ions. NH4 plus OH gives H2O plus NH4 plus Cl. So aqueous, they are all aqueous. Water is liquid. Okay. Finally, in order to write the net ionic equation, you need to cancel out the spectator ions. What are the spectator ions? The ions that remain without any change on the right and left side of the equation. Ammonia, Cl are cancelled out. What's left? You will write it. I have hydrogen remaining here, and OH, and H2O is the final product. This is the final ionic equation. This question is asking about the chemical reactivity series. Student has set up 4 beakers, each containing 100 ml of dilute hydrochloric acid HCl. She added 5 gram metal to each beaker in this order: aluminium, and then copper, and then sodium, and then zinc. Which metal will not react with acid? So she has got 4 beakers. Each of them contain equal volume, which is 100 ml, of hydrochloric acid. She added metal in each of them. In the first one, she added aluminium. In the second one, she added copper. In the third one, she added sodium. And in the fourth one, she added zinc. Which of them will not react with acid? To be able to answer this question, you should look at the chemical activity series. On looking at the chemical activity series, you recognize that we have potassium, sodium, magnesium, calcium, aluminium, zinc, iron, tin, lead, hydrogen, copper, mercury, silver, and gold. So, on looking here, you will see that now we are looking for the element that is going to displace hydrogen. Okay, if the element lies before hydrogen, is going to displace it. Aluminium, yes, of course, aluminium is above hydrogen, so this reaction is going to occur. Secondly, copper. Copper lies below hydrogen, so it never replaces hydrogen. This reaction won't occur. Sodium above hydrogen, and it's going to displace it. Zinc also is going to react with the acid because zinc lies above hydrogen. So the only one which will not react with the acid is copper. And this is because, according to the activity series, most active metals like aluminium, sodium, and zinc lie above hydrogen and will replace hydrogen, while the least reactive one will not. Last question is about the resonance. Is asking, draw all the resonance structures for ozone. Ozone is O3. By looking at ozone, as I have been said before, that the resonance structure happen only when you have alternative single and double bond. Okay, so very simply you are going to draw single and double bond, change the position of the double bond. So now you have two resonance form for ozone. Then what's left is to draw the remaining electron. Oxygen is in group 16, has 6 electron outer shell. Here it shares 2 electrons with this O, so 4 electrons are remaining. This oxygen atom, it has 6 electron outer shell and it does share 3. Means that in this atom you are going to write 2 electrons because one of the you should draw 3, but the third one is going to go to the other atom. This one 1 2 3 4 5 6, because 1 electron move from this oxygen to that oxygen. It's not important to know that. Just when you see double bond, draw 4 electrons. When you see single bond, draw 6 electrons. And when you see triple bond, just draw 2. Okay, because this oxygen now is surrounded by 3 bonds, like that one. Oxygen had 3 bonds, just draw 2 electrons. Here, single bond, draw 6 electrons. And on the other side, double bond, just draw 4 electrons. Now we left out with this question. In photosynthesis, water and carbon dioxide react in presence of sunlight and chlorophyll to produce sugar and oxygen in plant. Explain why photosynthesis is not really a synthesis reaction. Because the synthesis reaction gives only one product and the photosynthesis produces 2 products. Let's write the equation for photosynthesis. If you remember it, it's carbon dioxide reacts with water to produce sugar, glucose, C6H12O6 plus O2. Of course, you will not be asked in the exam to write the equation. It's just a reminder for you. 6CO2, 6H2O, and give here 6O2. I cannot consider it a synthesis reaction, although we call it photosynthesis, because we are making food. But food is not the only product which is given from photosynthesis. Also, oxygen is another resultant. So it's not really a synthesis reaction because 2 products are formed that are sugar and oxygen. Thank you. Remember that in the exam you will be given those tables. This table is for solubility to know if the salt will be soluble or not. Okay, these are the soluble ionic compounds. Okay, and here are the insoluble ionic compounds. Remember that also you will be given the chemical reactivity series, which show the trend of arrangement of element from the most reactive to the least reactive. Of course, also the periodic table will be given to you.